archaeology, which is my specialty, happens to be one of the oldest multidisciplinary fields. And with that, it lends itself in some ways. How many people have heard of Edmond Locard? A few. Okay. Locard actually never said Locard's exchange principle, but people constantly refer to it today because basically it's a law or a reference for how you work and what you find and how you make these associations, so that wherever he steps, whatever he touches, whatever he leaves, even unconsciously, will serve as a silent witness against him. Obviously, this is in reference to a criminal suspect. Not only his fingerprints or his footprints, but his hair, the fibers from his clothes, the glass he breaks, the tool mark he leaves, the paint he scratches, the blood or semen he deposits or collects, all of these and more bear mute witness against him. This is evidence that does not forget. It is not confused by the excitement of the moment. It is not absent because human witnesses are. It is factual evidence. Physical evidence cannot be wrong. It cannot perjure itself. It cannot be wholly absent. Only human failure to find it, study, and understand it can diminish its value. And with this is the underlying principle of everything that we do in this course and everything that you do as professionals in investigation. Locard said this many years ago, and you can see from his birth and date range that he lived to a ripe old age of 89. But hopefully we can take you and apply this principle into some other ways, moving from the known to the unknown. And as I told you yesterday, looking at things as they tell a story, with a beginning, a middle, and an end. In this case, our program was begun in 2005, and it builds on all these different fields: anthropology, archaeology, botany, biology, chemistry, entomology, geology, geophysics, material science, textile chemistry, engineering, statistics, physics, soil science, and many more. Forensic anthropology, Anne addressed, Dr. Ross, some things. These are some images that basically show you some of the field activities that have occurred in the past during these workshops and classroom studies. What they get at are applications of this knowledge for human versus non-human determinations. Determination of age, gender, ancestry, pathologies, and trauma. Forensic entomology, Dr. Bird has discussed, Dr. Watson has addressed in some of the field situations how to do collections and take this information in order to make more realistic and meaningful determinations of the time of death. You will learn throughout the week how to collect, how to identify, and by the end of next week you might remember some of this, but not all of it. Our purpose is to give you a tasting and then hopefully in the future expand that knowledge based upon what you learned during this setting. So postmortem interval, contributing information related to the cause of death, and environmental data all come from entomological studies. Forensic botany we're not dealing with in this particular case, this situation with this course. But we do in some situations, and we have access to one of the world's finest botany collections here at North Carolina State University. So again, applying this field in specific ways can contribute, addressed previously in the presentation, collection of botanical specimens, soil, and what information can be gained from that. Forensic geology and geophysics, Ron Croson addressed the GPR and the electromagnetic profiling yesterday. He also addressed some aspects of satellite imaging, which is a whole nother area, microscopy, and different light sources. Forensic archaeology, on the other hand, has to do with how you recover things from the ground, usually from a buried context, but many of the principles of this apply to the same situations, whether it's on the ground, in a room, whether you're looking at a victim. You're dealing with two important concepts: time, and space. These are the principles of archaeological investigation. And we'll say a little bit more about that because there's some basic questions that can be asked. So with forensic archaeology, the application of that is relatively new. The term is less than 15 to 20 years old. It arose out of the United Kingdom. So if we ask, what is forensic archaeology, the response would be it's the application of archaeological methods to theories and procedures to medico-legal investigations. There are two professional areas that certify people to be a professional archaeologist. One is called the Register of Professional Archaeologists, which I am the only person in this state that applies that in a forensic sense and has been certified by my peers. The American Academy of Forensic Sciences, the General Science section, also has an area for forensic archaeology. It is a relatively recent field, as I mentioned, established in the UK. Constantly, as Dr. Bird mentioned, every field encounters the CSI effect. What's shown on television shows the resolution of a case in 58 minutes or less. In actual practice, as you're going to learn starting today, it's not that simple. Well, what is archaeology? Archaeology is a subfield of anthropology, which recovers material remains to reconstruct past lifeways, activities, and events. It is multidisciplinary and draws heavily from other fields, including many of those that we've mentioned repeatedly through this course: geology and geophysics and chemistry and some others. Applying this to an investigative process, the discovery of buried human remains is one of the major areas of application for archaeology, using either traditional or remote sensing equipment. Many archaeologists today rely heavily on remote sensing equipment to discover buried artifacts, burials themselves, or other aspects that are left behind by past activities. This can be applied to criminal investigations as well. But generally, you're looking at buried bodies. Archaeology has to do with rigor. It has to do with a multidisciplinary background. When I say rigor, I mean it has to do with not taking shortcuts and understanding what a situation is. Looking at the process of formation for any type of activity, including a burial. Fine-grained strategies can be used to recover types of information that ordinarily might not be recovered otherwise. And you're going to see a case example of this and some of those types of applications. So how can archaeology contribute to criminal investigations? Well, first of all, it can clarify when an activity or an event occurred in time and space. You can apply sophisticated methods to make discovery and recovery more meaningful. It can assist in recording the evidence of the site formation process, and particularly it can identify certain laws that can aid you if you're trying to explain something in testimony. Steno's laws we'll talk about a little bit later in this presentation. But basically, the interdisciplinary nature of archaeology and forensic science programs is highlighted through some of the courses that we've offered: Bugs, Bones, and Botany, Discovery and Recovery, and we'll have more as we go forward. But they have to have a beginning, and the beginning lies with certain observations that were made with long ago by Nicholas Steno in the 1600s. These observations are three laws. The law of original horizontality, which has to do with sedimentary deposits, and that if you took something and laid it out and then added something else and something else and something else, the oldest of those sediments or whatever was laid down would be the one on the bottom, and the most recent would be the one on the top. And this is what he observed. that superposition occurred. In depositional sequences, the oldest material, or first deposited, occurred at the bottom, and the last deposited occurred at the top. And you may think this is very simple, but it's frequently not something that's observed as a process, but it is actually a natural process. When that stratified sample, think of a layer cake, and the layer cake has the different layers. And if you had somebody come in and take a swipe out of that layer cake, you would know intuitively that that event took place after those layers were deposited, after the cake was baked and the icing put on it. This is called the law of cross-cutting relationships. And it's when a deposit which cuts across another intrudes into that deposit, that stratified deposit, it is younger than the ones that it cuts into. And we'll see some examples of that. Well, how do you apply archaeology at a burial site, which we're going to see as we go into the field setting? Well, first of all, we've got to have some organization. Now, at crime scenes, you've probably seen the good, the bad, and the ugly. The good would be very detailed, very rigorous, and all the time in the world that you would want to have. More frequently, that's not what occurs. So you have to do something, do your best, and get out. In a worst possible situation, you have somebody come in that does not follow an organized pattern, is not detailed, and you end up with a corrupted scene. And this occurs more frequently than we would like. But as Dr. Hinks mentioned, conduct a thorough visual examination of the environment is important in dealing with color, but it's also important in archaeology because you have to assess the environment from the outside, looking to the inside to develop a plan and an understanding of how to approach the scene. So in our case, and if you look through, or if you've already looked through the workbook, you'll see a step-by-step process which mirrors most organizational plans, where you have someone that is in charge of the scene, someone that records the scene, someone that photographs the scene, and then you have people that follow instructions to recover the evidence inside the scene. Not too long ago, there was a feature on Dateline about a case that happened in 1991. One of the major problems of the case was that the scene was left open to various visitors, most of them law enforcement, but at least 15 people entered the scene before it was cordoned off, before it could be viewed in a controlled setting. This included the local doctor who came in, looked at things, walked around, turned around, went outside, came back in. And so you had a lot of corruption of the scene that occurred. In our situations, your job will be to establish control and delegate responsibilities. And what we're going to try to do is be very systematic in the recovery of even the most basic information. In an open area or grassland, which you're going to be working in, you'll have to adjust your plan. If it's forested or tree covered, you'll have to make some adjustments. If you were inside a building, which we're not going to be doing this time, again, as Dr. Bird mentioned, you could have different other aspects that you would have to do here. Determining the strategy that you apply, first of all, observation of the scene, and then conducting what's called a pedestrian survey in archaeology, but actually is a walkthrough of the scene. This is not done by 5 people or 10 people. It's done by one person who observes observations and reports them to the recorder. So if you see evidence of textiles or evidence of depressed vegetation, or if you see evidence of particular activity or scavenging, it's something that you know occurs within inside your cordoned off area and can be addressed very specifically. So surface irregularities are something that should be noted, but most people just don't see those things. We're going to look at some specific examples of those. If you bury a body in an open field, as we discussed yesterday, when you dig the hole and then refill it, the fill that fills the hole is less compact than the surrounding soil. So over time, that soil compresses and you get a depression. What happens over a longer period of time? Does that depression stay there? Anyone? No, it fills up gradually because you have vegetation that collects there. You have seasons that change. You have leaves that blow and fall. You have grass that grows and fills it in. It rains, and rainwater flows to the lowest level, so it carries with it vegetation and small particles that fill those in. This is called slump in our term, and then when it's filled over, it creates a more level, even surface. However, sometimes people, wanting to be clever, pile more dirt onto something trying to adjust for the depression so that it's more easily hid and blends in with the landscape. This mound-like activity is something to note. Disturbed soils have their own characteristics, but most importantly, what happens with disturbed soils is that they provide a fertile ground for certain types of vegetation. What are the plants that first grow in disturbed soil? Anyone? You know? They're weeds. Weedy plants are the first to respond to disturbed soil. So something like rubus, blackberry bushes, will grow first in disturbed soil. You also have many other plant species that will do that. But basically, looking at the collection and recording of evidence at the scene, we want to deal with how we position ourselves, establishing a permanent datum, tying it into something that's not going to be plowed over, run over, or removed in some way. We also want something that's not going to deteriorate. And one of you, we had a discussion about using rebar, about sinking it into the ground. There are a number of different processes which we can talk about in doing this. Many people rely on GPS systems, and we've already seen some deficiencies in that. But we're going to address these things this afternoon. And so whichever team is working on the buried body situation, as well as the scattered remains, you will be applying these things, which are all discussed in your workbook. Applying remote sensing, we're going to do a walkthrough of this over your individual scenes, using whatever equipment would be most suitable to that particular environment. These are illustrations of electromagnetic profiling, the top slide, this one right here, and this is ground penetrating radar. And as we have previously discussed, the electromagnetic profiling equipment casts a beam much like a flashlight on the ground that is about 6 feet in diameter. This is good for broad open areas. When you have specific targets or specific anomalies and close interval, then GPR becomes a very viable option. However, the operator and the equipment are critical to this, or the capability of the operator, I should say. Looking at vegetational changes, if you look at these particular images and you look at the grassy area here, most people would look at that and say, oh, that's just grass. But there are things here that we're going to learn about that could be observed from photographs. But more importantly, if you were investigating the scene, there are things that are clues to what happened in the past by understanding the process of change that occurs through time. Look for concentrations of weedy plants at crime scenes for the reasons that I've specified. Disturbed soil, these are the first plants to grow. They're going to be different in color. They're going to be different in size from the other types of vegetation. Increased and decreased color can both result from this type of activity. It depends on the plants. Soil compactness and density is another thing to look at. And when you have excavations, where you're looking at an underlying soil deposit. As you see in this particular slide, we're going to look at it more closely in a minute. Redeposited fill has a very characteristic patterning. The word for this is called mottling. And mottling is basically a mixture of colors because multiple layers of soil have been penetrated and then redeposited as a single unit. And that's what creates this kind of speckled pattern of color. Soil density can be determined by a number of factors, but yesterday you saw metal and fiberglass probes, so compactness, density can be determined with these as a simple field measure. Soil cores can extract samples so that you can actually take a small sample and keep that as evidence. It can be analyzed later by a soil scientist. Bucket augers and other types of stripping can be used in broader areas if you were looking for mass graves or whatever. So soil coloration and composition, as we see in this slide, you can see a dark soil, a lighter soil, and a slightly reddish-orange soil. This modeling indicates that it's been disturbed. It's been dug up and refilled. Shovel marks can be identified at the base of this feature, but also you can tell by looking at the surrounding edge that there was a particular type of implement used to dig this hole, a round shovel. In another area, you could see where a flat shovel was used. Again, cross-cutting relationships, Steno's law, can help us interpret which came first because there are multiple holes here and multiple episodes of digging. Mechanical soil removal is probably something that you won't encounter, so I'm going to skip through that pretty quickly. If you had something like a mass killing with multiple burials or a large burial pit, then mechanical equipment stripping off the soil provides an expedient measure to get down to what we call top of subsoil. There are pieces of equipment that are more effective for this than others. Stripping subsoil, and I'll show you some slides in a little while about what the top of subsoil looks like and how you can do that. Basically, in archaeology, we look at things with 5 questions. All of these begin with the letter W. The first 2 are where and when. And where and when have to do with time and space. And it could be over a large area of space or a small area of space. So where were the remains discovered? When were the remains deposited? Who is represented by the remains, which is really the domain of the anthropologist? What is unusual about the remains, if anything, which also addresses anthropological questions? And why were the remains found as they were? This has to do with process, the process of digging the hole, placing the body, and how it was covered. So if you looked at a slide or an image like this, what you see here is an excavated area. And you notice this is not a hole. It's actually a very precise square, or in this case rectangular excavation, and on this wall you can notice lines that demark the stratified layers of soil. The layer from this point to the top of the surface is plowed soil. Almost every soil in North Carolina has been plowed as long as there have been white people here. More frequently in the past 50 to 100 years. You can actually tell the difference between a mechanical plow and a single-bladed mule plow if you know what you're doing. Sometimes evidence of disturbed soil and agricultural practices can be stacked one upon top of another. More frequently, you only have one horizon. The underlying layer has more organic material in it, and at this particular site, it represents what we call a humic layer. But below it is a subsoil, which is more clay-based, And as holes are dug into this and penetrates into the clay and then refilled, they leave characteristic stains. And so here, and this is an archaeological excavation, you have a stain which is slightly oval or rectangular shaped. But if you look at it closely, you can see an area in the center, demarked by this line, which represents an area that's collapsed and then been refilled. And the reason the outside layer is as it is because everything collapsed inward. All of these observations must be documented, recorded, to be meaningful. When you begin excavation of a feature like this, everything begins from the outside in. Many criminal investigations, you have use of mechanical equipment which comes in, you pull out a slot trench, which is an avenue into the burial, and then you pull out the remains and send them to the medical examiner. This is particularly not very effective. The most effective way is to excavate in exactly the reverse order in which it was deposited. The reason for this is that it can reconstruct the scene. It can also allow you to isolate within certain deposits certain types of evidence that relates to the time-space continuum. So here you have an excavator who is excavating fill from a pit, which in the book it describes working from the center, leaving a buffer, working downward within 1/2, which the feature has been bisected, noting changes in topography, soil color, and texture, working within your grid system, working within the pit outline, which you saw earlier in the slide, and marking a visible border that keeps you under control. Control is a key word here. And because of that, when you're working around bone in particular, in this case you see someone elevated on a plywood platform working down into a pit. This is not fun. This is also not fun with something that has a lot of tissue on it. A decompositional burial, this is not good. So sometimes you have to modify this. Some of the SBI people in the audience may be familiar with a particular case that happened in Chatham County. The victim was buried over 30 inches deep on a hillside. This type of approach was used, but to remove the body, because it was encapsulated in plastic, we had to take mechanical equipment and create an avenue or a transect, a slot trench in below the placement of the body, so that we could actually get down and work into it. This was done after the preliminary excavation in this manner. So when you excavate into a pit, you have two choices. One is to use the pit as it was dug and remove everything in reverse fashion. The other is to excavate over the top of the pit so that you create basically a box or a sub-platform, which we'll look at these things, and supplement that with a trench or a slot area to remove the actual remains. Excavating burials are only done with hand tools. You don't want to use shovels. You don't want to use mechanical equipment, because all of these can damage or destroy the bone and other types of evidence. So looking at what is shown in the photographs, you see skeletal remains beginning to show up. You see a tedious excavation. This excavation took 3 to 5 days to complete. Now, this is archaeological. In a criminal situation, you can have this done within 12 hours or less. Cleaning around bone, exposing bone, and here you see a skull being exposed, you see soil scattered about, and you see an area that's already been excavated. When bone is found, you can work around it rather than directly into it, because what you want to do is keep the bone protected, encapsulated in soil, And by working around it, you can work to the bottom of the pit. How are you going to know the bottom of the pit? It happens to be more resistant than the fill that is inside the hole. The same thing for the edges of the pit. So if you find bottom, you can follow the bottom up to find the edge, and you get the actual hole that was dug, not something that you create. And in this case, you have an archaeological burial which shows the hole that was dug in the 1600s. This is after 300 years. And what you see is an area with a little ledge and then a central chamber with the burial placed in it. This ledge had logs placed across the top of it. So the victim was within an air-filled chamber. Over time, those logs deteriorated and the soil collapsed inward. And when it did, it allowed a depression to form, and that depression was what we saw looking at the top of subsoil. So, dealing with remains, we have to take special measures to pedestal bones, to expose everything before anything's removed unless it's something in our way. We want to brush bone consistently in one direction only, not like you're painting a wall. So it's one direction, clean your brush, one direction, one direction. If you don't do this, when you brush the soil off, you're going to reapply it with the next stroke. So there is technique to be mastered if you want to do it well. And all of this can be documented so that at the end of the period, and here you have the 300-year-old burial. So then looking at what's been excavated, you can see the bottom of the pit, you can see the side edge wall, you can also see the skeletal remains. What's important here is that the side edge wall contains marks from a sharpened stick and a stone hoe that was dug, that was used to dig this pit. So you can recover information sometimes long after an event has taken place. Well, how do we apply that to a criminal situation? This is an example. So in this case, we're dealing with the Terry Lee Webb case, which occurred in Fayetteville. A soldier went missing, as I told you yesterday, in 1991. Information came to authorities that led to an investigation. The 20-year Army veteran was reported as missing. His vehicle was found in one place, his apartment was ransacked, but no evidence of him. He was declared AWOL. After a few years, his family went on the Montel Williams show and brought a psychic from Durham to do a reading, basically, of where their father was. The answer was that he's somewhere near Fort Bragg, and he's buried. He's deceased. Well, I think most of us could have predicted that if he'd been gone for 7, 8, 9, 10, 13 years. But the bottom line was that when the investigation actually was undertaken, we were able to develop information which you see depicted here in a story that was called CSI Backyard. And this combined geophysics and archaeology, some other disciplines, with law enforcement to actually investigate this scene. The local authorities had information that led them to a residential location. The information they had from a federal informant was that someone named T had been murdered and then buried in a residential area, but that's all they knew. So a review of the case files indicated that T was a nickname for Terry Lee Webb, and he was a missing person. They began to look closer, identified a potential suspect who in 1991 lived with his mother and stepfather in an area of Fayetteville. So a plan was developed to go to the scene and investigate. Someone had the idea to use a bulldozer once the search warrant was issued and bulldoze the backyard, and we'll find the remains. If that had been done, the story we're about to discuss could not be told. So looking at the scene and observing the scene, what was found was that you had a residential house, a residential backyard, a storage building, and not a lot else. What was done through the investigative process was to use satellite images taken before and after the event in 1991 that showed at that time there was an aluminum outbuilding, typical aluminum storage building, where this wooden 12 by 24 building now sits. It was also observed that there was very little in the backyard except for toys, very few plants, different things. A base map was done, which you see illustrated here, showing the location of the house, the storage building, and a brick-type patio. Nothing else was there except for a fence that enclosed the yard. Initially, a cadaver dog was run through the yard in order to make this expedient for the dog. Someone preceded the dog with a probe, stuck it into the ground, the idea being to release the gases and the dog would get a better hit on whatever was underneath. In actuality, the dog really didn't get any hits. He did yelp once at the corner of a building, but it was not very productive. The electromagnetic survey was conducted, and here you see Ron Croson with the device you saw yesterday. Within a grid, which this line represents the mark nearest the fence, and the data that was collected was done by walking over the area. Several targets were identified, and ground penetrating radar was then applied to these targets. What was found was a septic field, some underground pipes, and not much else. Looking at the building itself, the observation of the building showed that there was an addition that had been built onto it, but it also showed a concrete foundation, some fractures in this, and applying Steno's laws, which we talked about before, that sediments are deposited horizontally, the same applies for things like concrete and foundations and soil. And these things have a relationship, superposition, and cross-cutting relationships that can be interpreted. So when you look at the scene, which I showed you before, and you look at the image here, you see an area of about 9 inches of concrete that's been poured. But if you look carefully at where the arrow directs your attention, you see a slight depression. And beneath that, you see some more concrete. What this tells you is that this has been less compact soil and that it has compressed. A closer view shows this more clearly, and you see actually more than one depression. You also see clearly that there's an underlying superimposed layer of concrete, but in actuality this is not concrete. Concrete is a particular mixture that has clastic particles in it. This happens to be Portland cement, which is hand mixed, not poured by the cement truck that pulls up and deposits it. Throughout the investigation, what was learned is that there were 7 inches of this particular mix and 9 inches of the concrete, a total of 16 inches of concrete, which formed a foundation or 2 foundations for this building. You could have parked a tank in this building. So the cement and the Portland cement or concrete actually was overkill for the type of structure that was here, much exaggerated. And looking at it straight on, again, you see the 9-inch and 7-inch areas, and you see a closer view where some of the overtop deposit has spalled off because it was thinner and wrapped in to cover that. Looking at excavation at this scene, what was done is that the vegetation behind this structure was removed by hand. And some of the first areas to be excavated showed this. And if you look carefully, you see a dark soil. Of course, here's the grass. And this is about 6 inches deep, but here is some bone. Here is some very characteristic modeling of the soil. And you should say, what does this tell me? It tells me that this soil has been disturbed. It's been dug up and redeposited. So soil discoloration and modeling indicates prior disturbance. If you can't recognize this, you have a problem. Small bones, in this case, are phalanges. They're not in a particular articulated order like you would find with an outstretched hand. They were mixed within the soil. A close photograph shows some of the bone. There's actually some cut marks or marking, scraping of the bone. All of this was done to scale, but more importantly, here's a closer view of the soil and the mixtures. So you have the dark organic soil, a light-colored clay, and ultimately we'll see a third type as we go along, which is an orange clay right here. And also in the soil, there was a shotgun shell casing, and this was also in the mixed soil. Well, it's not necessarily an indication of a homicide or a relationship to our event, but it was something to note that was recovered in this particular manner. Whenever it rained, the scene had to be protected, but more importantly, as the excavation was conducted, what was found were no large bones. No femurs, no tibias, no skull, no humerus. What was found were small fragments of what once was, and this is one such example. So this is a cranial fragment, and you see it's rather angular, but here is where it came from. So in this case, we're looking at an area that has been exposed, and if you look carefully here, here's our ring pin, here's the edge of our excavation, here's the lower edge, and then another area that has been excavated slightly ahead of this. Everything you do in excavation is moving from the known to the unknown. It's using the excavation itself to guide your progress. So if you encounter something, you don't blow through it. You recover the information, and by doing it in halves, if you make a mistake, you've still got another half that you can pursue in another way. If you look carefully, you see a dark area right here, sort of a line that follows the cursor, and here is another modeled area, but look at this. It's very dark and homogeneous. What this tells you is that this portion was dug by a square shovel or spade in a rectangular excavation. This is the natural subsoil. This is disturbed fill, and this we haven't seen yet. But looking at the other side, here we can see an area of great disturbance. We see elliptical curving lines indicating a round shovel. So we have indications of at least two tools, possibly more, probably two suspects, not one, but it could be one person at two different times. So looking at this example in the image, we see the soil discolorations that we've been talking about, dark, light, and the slightly orange. Why is the orange soil here? What does it represent? What? Clay? Okay, but where does it come from? Somewhere else, right. Well, what we'll learn this afternoon is that before you go into the scene, you do a controlled excavation so that you know what the soil stratigraphy is. And if that had been done in this situation, which it was, you would know that the upper level of soil was a dark brown, the underlying soil was a light tan color, and at about a depth of 2.5 feet, there was a clay deposit that is orange. So finding this mixed in with this soil tells you that this hole has been dug and penetrated down to that clay layer. So it's at least 2+ feet deep. So that helps us guide in what we can do and to get the soil out. Well, going back to the geophysics and the investigation, what we see is that we have the backyard area. You can see these radiating different colors in these areas, which represent reflection of the radio frequency from metal objects. But if you note, the wooden storage building also has something that shows a radiating pattern, particularly here shown in red, to the back of that building. That is an anomaly. It shouldn't be there. There's nothing metal that would reflect, and in this case it represents the area of disturbance where a pit had been dug. So if we take everything that we've gathered thus far and look at it, we can see in the upper slides that you have an excavated area that shows multiple areas of disturbance, multiple tool use, and in this example you see a profile showing the distribution with small skeletal fragments in a rather rectangular pit. The disturbance behind the wooden building, the ground penetrating radar, showed a V-shaped pattern, which is indicated here, which was actually created by a debris field. The debris field was where soil had been excavated, and it contained glass and metal objects that were cast over one's shoulder and deposited in the area that was excavated. And this is the area of the major burial itself, which is shown here a little bit more closely. So we actually have two separate events represented. We have the initial digging of a pit and the placement of the body, and then at some unknown time we have re-excavation of the pit and refilling of that. When it was refilled, the person or persons that dug it did not get all the skeletal remains. The small things were small things forgotten, and these were left as all the remains of the victim. So when we look archaeologically at this, and we divide the feature in half by a line, which is represented by this string, which is called a cross-section line, and it creates an area to be excavated which gives you a vertical profile, where you can use this to judge the excavation of the unexcavated area that lies behind it. Now we're going to look at that and see what we can tell from this. Well, one thing is, when you encounter an object within an area that extends into the unexcavated area, it helps you judge how to remove it, because if you pull it out, the profile is going to collapse. So you want to leave it, expose around it, work around it. In this case, underneath the cranial fragment was a skull fragment. Applying Steno's law, we can tell that the skull fragment was deposited prior to the piece of concrete. So we're continuing in reversing the sequence, going through the soil, and if you had to testify to this, you could say, this is how I know what I know. It's called epistemology. The yellow dotted line that you see here represents the extent of the piece of cement block that was found in the fill. Well, why would it be here? It was actually placed here during the second episode of digging because there wasn't enough soil to refill the pit. So by placing the cement in there, it took up some of the space. And here in this profile, you can see some other debris, bricks, and other items that were thrown in. This colored area represents the bottom of the pit. Within the soil and sifting the soil was recovered a textile fiber, which you see here, demonstrated by the arrow. It's a red colored fiber, which, as Dr. Hinks indicated, could be identified, and it was. It actually is the thread used to stitch together a pocket on a particular type of pants. But under the cement block, the cranial fragments that were found, the problem becomes, how do you deal with the cement block? And ultimately it was excavated, and because there was a potential for it to contain things within it, it was cracked like an egg. And all that was done is a tap on this, and it split into two fragments. Inside this was a human maxilla, which you see shown here. And you'll notice an area surrounding the maxilla, which is slightly brown or discolored. But when cleaned, washed away, it presents a cavity. What this tells you is that the tissue that was formerly here has deteriorated, but that the cement was applied over top of this while tissue was still attached. Again, it's Steno's law. It has to do with the sequence of events that occurred. Within this block, which was retained as evidence for presentation in court, a CAT scan was done, and a shotgun pellet was also identified within the cement matrix. As the area was being excavated, fragments of cement became more numerous, and they actually fell from underneath the layer I showed you before, the 7-inch cement layer. And included in these were fragments of bone, including fragments of a mandible that had a surgical alteration. What had happened was that the victim had been placed in a hole, and Portland cement had been mixed and poured over top of the body. And when it hardened, some of the fragments were embedded or attached to the cement themselves. The reason that we're seeing all these fragmented remains of the crania is that the victim had been shot in the face with a shotgun. So things began to come into place where the various different images could form a more coherent picture. Using interdisciplinary knowledge, applying this, the Terry Lee Webb case was brought to a close. Suspect was arrested in Afghanistan, brought back, and pled guilty in trial. Forensic archaeology, forensic science in general, can make use of many different areas, including those things that we've talked about. Many of the most important areas that are unfamiliar to people include archaeology, entomology, botany, geology, and anthropology. These are things that we're going to look at today and the rest of the week, and we will focus, as I have told you before, on the science of these things, being able to replicate certain types of activities and being able to understand the processes that are involved in these investigations.